Welcome to section 7.4, where we will be discussing the Ewoks and more about their planet. What? It's like a Star Wars reference. You might remember way back in the day, like our second day of class, we had a lesson about the real number Death Star, and it went a little like this. Welcome to section 1.2, the real number Death Star. The Death Star! It's Star Wars Day! Extreme close up! Wow, it was probably this lesson that you realized I was kind of crazy. But I did do a good job outlining the different subsets of the real numbers. We started with the natural numbers, numbers like 1, 2, and 3. We then added another layer of the Death Star and included the number 0. So we had 0, 1, 2, and 3, and so on. We called that layer the whole numbers. We then added another layer after that, and we included our negative numbers like -3, -2, -1, and also 0, 1, 2, and 3. And we called that layer the integers. We then had one outer layer. It's the biggest layer because it has lots of numbers. We called this layer the rational numbers. And rational numbers are any numbers that can be written as a fraction. Rational is fractional. So any of our fractions, any of our terminating decimals, and any of our repeating decimals fall under this outer category. We then had one last subset of the real numbers, which made up the weapon of the Death Star. We called these numbers the irrational numbers. I even had Admiral Akbar. There he is. It's a trap. We then drew the weapon. Irrational numbers are numbers that go on forever and have no pattern, like pi, square root of 3, square root of 5, things like that. So here we are in chapter 7, and you might be asking, Brother, why are you talking about stuff that we talked about like on the second day of class? We're way past that. Well, believe it or not all numbers are real. Not all numbers are here in the real Death Star. They can't be classified as natural, whole, integer, rational, irrational, or real. In fact, we have another entire planet full of numbers that we have to discuss about today. And those numbers are known as the imaginary numbers. Imaginary numbers. Now, you should be really careful here because imaginary numbers are not imaginary. They're actually real, and we use them in the real world all the time, especially in engineering and especially when dealing with electricity and lots of other situations in the real world. Sadly, many years ago, back in like the 17 and 1800s, somebody named them imaginary, but they're not imaginary. And you should think of them as a new type of number. They don't exist here in the Death Star. In fact, we should put up a different picture. The imaginary numbers are on the moon of Endor. Here they are. Imaginary numbers. The Death Star are the real numbers. It's in a totally different location, totally separate from each other. Okay, it's like a new world. You could think of the imaginary numbers as the Ewoks. You'll just have to spell Ewoks with an I because that's what we're going to be using to represent imaginary numbers. So real numbers, they were stormtroopers. They lived in the real number Death Star. But down on the planet of Endor, there's another type of number. They're called imaginary numbers, and they're like the Ewoks. Oh yeah. So today we got to talk about how imaginary numbers worked, where they came from, and how to do math with them. Let's go. So imaginary numbers come from square roots, a specific situation that occurs with square roots. So we all know that the square root of 25, well, that's just 5, right? You could write this as the square root of 25 is 5 squared, and a square root and a power cancel out. We're just left with 5. However, if we have a negative number under the square root, we got issues. Because there are no two numbers that you can multiply by to get a negative, because if it was -5 times -5, well, that would get you a +25. And so this doesn't work. And so in the real world, mathematicians and scientists needed to come up with a new number that would make this work. And the number they came up with is the number I. Anytime you have a negative under a root, if you have a negative under a root, this is going to be an imaginary number. And we'll use the number I, or we'll use the letter I, but it's really a number, to represent that we had a negative under a root. So by definition, from now on, we'll use, anytime we have a negative under the root, square root of -1, that is going to represent I. And so for this problem, the square root of -25, we would just throw this negative out. We'd say, oh, well, that's going to be I. And the square root of 25 is 5. So we would write 5i. The square root of -25 is 5i. We just take the square root of 25 like normal, and we write I to help us remember that it was an imaginary number, that there was a negative under the root. So we can simplify all types of numbers now. Square root of 4, well, that's just 2. But since it was negative, we're going to write 2i. So what's the square root of 36? Well, the square root of 36 is 6, but because it was negative, we write the number I behind it. Square root of 40, oh, I don't know that one, but we can break it down into 4 and 10 and 2 and 2. We've got a wedding, so those guys get married, become 1, and left inside is a 10, because 2 and 5, that doesn't break down. But because it was negative, we'll write an I outside of the root. We write an I outside of the root to remind us that it was a negative under the root and that this number is imaginary. It's your turn to simplify some roots here. Go ahead and pause the video, and in your video notebook, simplify these roots and see what you get. When you're ready to check your answer, unpause it, and we'll see how you did. Okay, let's take a look. So we've got the square root of 81. I know that the square root of 81 is just 9. In fact, if you didn't know that, you could break it down into 9 and 9, and you'd say, oh, look, we've got a wedding. They move out of the house. But because it was negative, we write the number I behind it. This is an imaginary number, 9i. Good. Square root of 50. Well, that's 5 and 10, which is 5 times 2. Ooh, we've got a wedding. So these guys move out. 5. Left inside is this 2. But because it was negative, I'm going to write an I on the outside. So we write the answer as 5i root 2. This is an imaginary number. It's imaginary because there was a negative under the root. We can add and subtract imaginary numbers as well. For example, if I had something like 3i plus 7 plus 5i minus 2, we can combine these numbers. Adding and subtracting, all you have to do is combine your like terms. Combine like terms. Just like we would do in normal math with any normal variable, I would combine my i's with my i's. 3 i's plus 5i is 8i. And 7 minus 2, well, that's minus 5. And so that's what this would equal when we added these numbers together. You combine your i's with your i's, your numbers with your numbers. When we add and subtract Ewoks, no rules change. It's the same as the Death Star. Just combine your like terms. Go ahead and try question number 3 and 4 here. Pause the video and let's see if you can add and subtract imaginary numbers. Good luck. Okay, let's see how you did. On here, we just got to combine our i's. If we had 6i minus 4i, well, that's just 2i. That's a pretty easy one. Here, ooh, we've got some parenthesis and a minus. You're going to want to distribute the negative in, just like we would in the normal algebra. We go minus 10i plus 3. Don't forget to take that minus to both the values in the second parenthesis. And then we add these i's together. 3i minus 10i, well, that's negative 7i. And 5 plus 3, that's plus 8. And so there's our answer on that one. We can combine i's and we can combine normal numbers under addition and subtraction. Now, multiplication gets a little harder. Multiplication with imaginary numbers is not like the normal Death Star, not like our normal real numbers. And I'll show you why here right now. Let's say that we wanted to take I times I. So if we had to do that, just in normal algebra, if we took x times x, we would just get x squared. And that's true here too. When I take I times I get I squared. But you have to remember the definition of I. We said that the definition of I is that I equals the square root of -1. That was a definition we used to represent I. We said, ooh, I is whenever we have a negative number under the root. So if I were to take this problem and say, okay, let's square both sides. If I was to say, ooh, let's take the I, this left side and square it, and this side and square it, we would find out that I squared equals, what would happen here? If I took the square root of -1 and squared it, the root would cancel the power and we'd just be left with -1. Oh, that's crazy. And so by definition, we are going to say that I squared equals -1. You're going to want to remember that. Write that down somewhere. Anytime you see I squared from now on in mathematics, you're going to want to remember that that represents -1. And so if I was given this problem here and I said, ooh, what's I times I would write, ooh, I times I equals I squared, and I squared is -1. We can have problems that look like this, 5i times 3i. Well, if you have 5i times 3i, you just multiply the 5 and the 3 together, that's 15. We multiply our i's together, I times I is I squared. And we have now stated that anytime you see I squared, you're going to just erase it and put in a -1. Because from now on, I squared always equals -1. So my final answer here for this one would be that I squared is -1, and so my answer is -15. I squared is -1. Okay, let's try it here. Here we're going to have to super distribute these parentheses. So 2 times 6 is 12, and 2 times a -3i is -6i, and 4i times 6 is 24i. And then 4i times a -3i is -12i squared. Now again, don't forget, anytime you write I squared, you have to write a -1. So this is going to be 12 minus 6i plus 24i minus 12 times -1. See how I'm writing a -1 here? Anytime you have I squared by definition is -1. So that's going to get me, let's add these all together. I get 12, -6i plus 24i, that's plus 18i. And -12 times a -1 is plus 12. So 12 plus 12, that's 24 plus 18i. Woo-hoo. Crazy. So imaginary numbers, these Ewoks do strange things when multiplying. Sometimes when you multiply them, you're going to end up with I squared, which is -1. Okay, let's have you practice multiplying some imaginary numbers together. Go ahead and pause the video and give these two problems a try. When you're ready to check your answer, let's see how you did. Good luck. Okay, so let's take this 4i into the parentheses here. 4i times 2i, that's 8i squared. And then when I take the 4i to the 7, that's going to be 7 times 4, which is 28. Now we're not going to leave our answer like this. That would not be allowed because we know what I squared is. I squared is -1. Anytime you see I squared, you're going to want to write -1. So our final answer is -8 plus 28i. I is all right to write. We'll always write I in our answer, okay? But not I squared. We know what I squared is. Okay. On number 6, we super distribute 8i times 2i, that's 16i squared, and 8i times a -7, that's -56i, -3 times 2i, that's -6i, and -3 times -21 is +21. 16i squared, that's I squared is -1, And negative 56i minus 6i is negative 62i plus 21. So it's really negative 16 minus 62i plus 21. And we can combine our numbers here. 21 minus 16, that's 5 minus 62i. What about higher powered i's? Oh my. So we said that we know what I is, and we said that I squared, we said I is the square root of negative 1, and I squared really is the square root of negative 1 squared, which got us negative 1. What would happen if we had like I cubed? One way to deal with these is to write out all the i's. So I would go I times I times I. And I know that this right here is negative 1, I squared, right? We could even write it as I squared times I. And I know I squared is negative 1. And so negative 1 times this other I here would actually get us negative I. Or what if we had I to the 4th? Oh, that's weird. So it'd be I times I times I times I. Oh, really, that's just I squared times I squared. So when you're doing higher power i's, get it in terms of I squared, because we know that equals negative 1. See, here I had I to the 4th, so I took these two, whoop, and I wrote it as I squared, and I took these two and wrote it as I squared, because that allows me then to write it as negative 1 times negative 1, which comes out to be positive 1. Anytime you have higher power i's, you just want to write them, get them grouped together, and get them in I squareds, and then convert the I squareds to negative 1. Now, what if we had something crazy? What if it was like, I don't know, I to the 10th? Ooh. So let's think about it. We could write out a bunch of i's. I, if you wanted to. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I. And then write it, this is negative 1, this is negative 1, this is negative 1, this is negative 1, this is negative 1. So negative 1 times negative 1 times negative 1. Ooh, negative 1 times negative 1 is positive 1. That's negative 1, positive 1. Oh, it's negative 1. So again, getting them in groups of 2 helps. You could also think if it was I to the 33rd, again, you could take, you'd say, ooh, how many pairs do I have here? You would do 33 divided by 2. Well, that's, let's see, 1. Take out a 2 leaves me with 3. So it looks like that goes in 6 times. And there would be 1 left over. So in other words, you have 16 I squareds. You have I squared 16 times, and then this extra remaining I over here. So if I did negative 1 to the 16th, negative 1, you could type that into your calculator if you wanted to. That's going to be positive 1 times I. So the answer here is I. Again, group all of your i's into pairs so that you can then convert them into negative 1. That's how we do higher powered i's. Higher power I. Sounds like I'm talking about like SpongeBob. I, Captain. Remember, I, or I squared equals negative 1. Okay, it's time for you to try a higher powered I. Go ahead and pause the video. On number 7, you're going to do I to the 7th. And on number 8, you've got to do I to the 40th. Woohoo! Good luck. Okay, on number 7, we've got I to the 7th. We could write out 7 i's if you wanted to. That's fine. Nothing wrong with that. And then I would pair them. So this is negative 1. This is negative 1. This is negative 1. And we have this leftover I as well. Negative 1 times negative 1 is a positive 1, times a negative 1 is negative 1. So the answer here is negative I. Cool. I to the 40th. Wow, you could write out 40 i's, but I really don't want to. How many pairs would I have? Let's see. I would take 40 and divide it by 2. I'd have 20. So really what I have is I squared, and I have 20 of them. And I know what I squared is. I squared is negative 1. And if you raise that to the 20th power, you get positive 1. Now you should be aware that I is a number, so you should be able to find it on your calculator. Might take you a little work to find it. You might have to push the second button. But it's kind of nice to be able to find I on your calculator because you can type it in just like a normal number. And so you'll see that when I do I to the 40th power, the answer is 1. Okay. The moral of the story here is if you have a number, if you have I raised to a power, you do need to simplify. Always simplify your i's if they're raised to a power. You might remember in our last lesson or 2 lessons ago, we talked about one of the deadly math sins, and that you can't have roots in the denominator. Now, because I equals the square root of -1, we can't have i's in the denominator either. No i's in the denominator. So if you ever end up with a question like this, I don't know, 5 over I, that's not allowed. Anytime you have that, you're going to have to multiply the top and the bottom by the conjugate. So I would multiply by I over I, and then just multiply across. 5 times I is 5I, and I times I is I squared. And I know what I squared is. I squared is -1. Don't forget that. You have to have that burned into your memory. You must remember that I squared equals -1. And so the final answer here is -5I. We could have something like this as well. We could have, I don't know, 3 over 2 plus I. Ooh, that's a deadly sin. No i's allowed in the denominator. No roots in the denominator. So again, anytime that happens, multiply the top and bottom. Multiply the top and bottom by the conjugate. In this case, we'll need to multiply not by 2 plus I, we'll need to multiply by 2 minus I. Multiplying by 2 minus I is the conjugate. Conjugate means change the sign. Now here, when it was only I, we didn't have to change any sign. You could have, but we didn't have to. But if it's a binomial, like 2 plus I, you need to write 2 minus I. And then we'll multiply. Let's see, 3 times 2 is 6. And 3 times -I is -3I. And on the bottom, I'm going to put these in parentheses, so I super distribute. 2 times 2 is 4. And 2 times -I is -2I. And I times 2 is plus 2I. And I times -I is -I squared. Ooh. Cool. Notice that on the bottom, the -2I and the plus 2I go away. And remember that I squared is -1. So really, we're just with 6 minus 3I all over 4 minus a -1. Do you see that? It's minus I squared is -1. So I wrote 4 minus a -1. And so our final answer then comes out to be 6 minus 3I all over 4 minus a negative. That becomes plus. And there's our answer right there. 6 minus 3I all over 5. So that's how we divide. Just like we did with the square roots, we're going to do with the imaginary numbers, because the imaginary number just means a negative square root. So the same rule applies. Okay, last 2 problems to the boards. Let's do it. Number 9 and 10, pause the video, multiply by the conjugate. Let's see what you get. Good luck. Okay, let's find out how it went. I'm going to multiply by the conjugate here to the top and the bottom. I'm not going to multiply by 3 plus I. I'm going to multiply by 3 minus I. 3 minus I. Okay. We're going to have to put these in parentheses and then multiply in, let's see, 8 times 3 is 24. And 8 times a -I is -8I. On the bottom, we get 3 times 3, which is 9. And then 3 times a -I is -3I, and this is +3I, so those are going to cancel out. And then I times a -I is -1, or -I squared, which is -1. Let's write it like that. I don't want to skip the step on you guys. Okay, so we get 24 minus 8I all over 9. This cancels out, and I have a minus I squared, which is a -1. Okay, so minus a -1. So these become plus, and I'm left with 24 minus 8I over 10. That's a pretty good answer right there. However, you're going to want to remember that if you can divide out a 2, you should. So I'm going to divide a 2 out of here to get 12, a 2 out of here to get 4I, and a 2 out of the bottom to get 5. You might have forgot to simplify it. That's all right. But just know on like a celebration of knowledge or in the book, they're always going to simplify their fractions. Okay, number 10. Let's look here. I got to multiply by the conjugate. That would be 2 minus 3i to the top and the bottom. 2 minus 3i. Ooh, we're going to have to super distribute the top and the bottom. Okay, let's do it. 1 times 2 is 2. And 1 times negative 3i is negative 3i. 2i times 2 is plus 4i. 2i times a negative 3i, that's minus 6i squared. Okay. On the bottom, we have 2 times 2, which is 4. And then 2 times negative 3i, which is negative 6i. 3i times 2 is plus 6i. Those are going to cancel out. And 3i times a negative 3i, that's minus 9i squared. Okay. Let's simplify this here. Might have to get rid of our green. Let's see. This is going to be 2. Negative 3i plus 4i, that's plus I. And that's minus 6i squared. Remember, this is just negative 1. So it's going to be plus 6 all over 4. This stuff cancels out. And this is negative 9, but it's going to be times negative 1 because I squared is negative 1. So that's actually plus 9. So 2 plus 6 is 8 plus I over 13. And that's our answer. And notice, we don't have an I in the denominator, so we are done. I leave you with this math joke. Here's the number I telling the number pi to be rational, and the number pi telling the number I to get real. I love it. Well, great work with chapter 7.4. Good luck on your assignment and preparing for the chapter 7 test. We'll see you in our next lesson. This is Brother O signing out.